Hello everyone, this is Yang from the National University of Singapore. The topic of my presentation is Shuffle, Play, Learn, Experiential Learning in Game Theory using Love Letter. Let me begin with the motivation. I teach an upper-level game theory course for the undergraduates. One challenge I identified is that students often face difficulties applying game theory to the real world. There are two necessary conditions for the application. One is the mastery of the theory. The other is the institutional knowledge on the real-world scenarios. From my experience, undergraduate students often do not fully understand the scenarios they're trying to model, which may lead to a situation where they make arbitrary assumptions on the real world to fit the model. To address this issue, I designed a group project following the experiential learning approach. Before applying game theory, students first build an experience by playing a card game in groups. This experience serves as the foundation for the application of game theory. After playing the game, students analyze their gameplay using concepts from game theory. The game I chose is called Love Letter. It's a strategic card game with 21 cards, representing 10 characters. To play the game, players shuffle the cards and take out one card without looking at it. Each player starts with one card in hand and takes turn to draw another card from the deck and chooses one card to play. When a card is played, the card effect will be resolved. Take the Baron card as an example. There are two Baron cards in the deck. Each Baron card is worth 3 points, indicated here. And what is the effect of the Baron card? When a player plays the Baron card, the player chooses another player to compare hands secretly, and whoever has a lower value card will be eliminated from the round of play. So why is this a suitable game for the project? The Love Letter game is a sequential game under incomplete information. In this game, strategic behaviors are essential. Moreover, the game is not overly complex. It takes on average 10 minutes to play a round, so it's possible to record a round of play and analyze it. Finally, the game is fun and portable. It doesn't require much physical space to play, so students can carry the game easily and play it anywhere. Now I will briefly explain the group project. These are the basic instructions. Students should form a group to play the game multiple times. They should choose one round of play they found most interesting, inspiring, or surprising. The assignment has two parts. In part 1, students record the playthrough of the chosen round. In part 2, students explain how knowledge of game theory is used or could be used in their selected round, using specific examples from their gameplay. The assignment follows Kolb's framework of experiential learning, which consists of 4 stages. First, by playing the game multiple times, students gain concrete experience. In the next stage, they engage in reflective observation by recording their playthrough of the game. Next, students practice abstract conceptualization by summarizing their observations and connecting them to game theory. Although the assignment does not explicitly require students to conduct active experimentation, analyzing one round of play allows them to learn from their experience and experiment with new ways of play in future rounds. Here are some more details of the assignment. It accounts for 15% of the final grade. Students were given 6 weeks to complete it, and in spring 2023, there were 16 groups in the course. I also made several clarifications on the project. For example, one potential concern is that students may perceive a positive correlation between how well the round is played and the quality of their assignment. If this is the case, they may feel compelled to produce a perfect round. To address this issue, I clarified that the assignment is not a competition for the best round. The project began with a hands-on briefing session in the middle of the semester. There are 2 key activities in the session. The first is that students were given some time to study the card effects. To check their understanding of the card effects, 6 active learning questions were given on Poll Everywhere. After discussing the solutions to these questions, students move on to the second key activity, which is to play one round of the game with their group mates. Although students were generally unfamiliar with the game, they learned quickly and answered most of the questions on Poll Everywhere correctly. Not surprisingly, students were excited and happy when they were playing the game in class. The briefing session took around 45 minutes. Now I will move on to the discussion of the learning outcomes based on students' work. There are 2 main learning outcomes for this assignment. The first is the application of game theory. I want to understand what concepts are applied and how they are applied. The second is the reflection on the gameplay. As students reviewed and analyzed their own decision-making, it's interesting to see whether students found any mistakes in their decision-making. If so, can they correct the mistakes? And can they reflect on why they made the mistakes? For the first learning outcome, among the concepts frequently discussed by the students, backward induction and first-mover advantage were generally well applied. On the other hand, dominance and best response were not so well applied. The main issue lies in the difference between strategies and actions in dynamic games. Since Love Letter is a dynamic game, strategy is not a simple action but a function that specifies an action at every information set. However, almost all groups discussing the concept of dominance or best response use the term strategy to describe an action. This shows the challenge students face in distinguishing between strategies and actions. Beyond individual concepts, students' application also showed different degrees of abstract conceptualization. Their performance mainly differed along two dimensions. The first is how well they articulated the connection between the concept and their decision-making. For some groups, the analysis was incomplete. Either they described the decision-making process without identifying the concept, or they identified the right concept but not how it was applied. The second dimension is how well students specify the assumptions they're making on the game or the players. Take payoff function as an example. Students often did not point out what payoff means to each player, whether it is the probability of winning or the probability of surviving the current turn of the game. Moving on to the second learning outcome, many groups found mistakes in their gameplay, but only a few discussed in detail how the mistake can be corrected using backward induction. For example, the following group reflected on the last turn of the game and concluded that player 1 should have played the Baron card instead of the Handmaid card, as the expected probability of winning is higher. Students also reflected on why they made the mistakes. The previous group concluded that player 1 was focusing on the short-term payoff of staying in the game. Another group, for example, realized that they were choosing the safe option to avoid the worst possible outcomes instead of the optimal option. Interestingly, students were trying to be rational. However, they faced difficulty working out the optimal choice during the game, and they resorted to simpler decision rules that do not require multiple steps of reasoning. This shows the difficulty in applying backward induction in a real-world setting. A few other groups reflected on the emotional factors behind their mistakes. Some realized that their decisions were influenced by their experience in early rounds of play. For example, the following group had a few rounds of play where players were eliminated early in the game by the Baron card. Out of fear, they started to keep the higher value cards in hand. They named it the Baron effect and discussed how it affected their decision-making. Another two groups observed that players often reciprocate during the game. They tend to target the players who attacked them in previous rounds and reward those who did not, even when it is not the optimal thing to do. In conclusion, the assignment allows me to better measure student learning. Moreover, it provides students with a concrete and relatable context to apply game theory. It also allows them a rare opportunity to reflect on their own decision-making. These reflections compel students to reconcile their understanding of the theory and their actual behavior, and help them establish connections between game theory and the real world. For these reasons, this assignment complements the traditional math-based exercises and enriches the overall learning experience of the students. The assignment was also positively received by the students. Students found the project interesting and enjoyed playing the game. Here are some comments from the students on the real-world applicability of the course in the student feedback. The assignment can be adopted in a wide range of courses. Since it is not mathematical, it's accessible to students at all levels. The assignment can also be employed in courses focusing on behavioral or experimental economics. As it takes time to read through students' work and provide comments, the assignment is ideal for small to medium classes. With sufficient grading support, it is easily scalable to large classes. Finally, other strategic board games can also be used for the assignment. I recommend choosing a game that is fun but not too complex. As a rule of thumb, it should not take players more than 20 minutes to play a round. This is all for my presentation. Thank you for listening.
Hello there. My name is Tim Burnett, and in this video I'm going to talk about the effect of group composition in group work on student academic achievement. Why is this important? Well, group work is ubiquitous. We all employ it, a lot of the time mainly in group assessment projects, but there is a real limited consensus on how group composition affects task performance. And the reality is that the effect of group composition is heavily moderated by the design of the task, the context in which it takes place, and in general the experimental design on how this is measured. But crucially, there is also very limited discussion, certainly in economics, of how groups and group composition can facilitate broader cooperative learning in students, so students learning from each other. So the big question overarching here then is that given that we ask students to work in groups quite often, can we improve students' outcomes by tweaking the composition of these groups? So we follow a large introductory macroeconomics module at a prestige Russell Group UK university, which has about 500 students per year. And this module runs for the entire academic year, autumn and spring. We look at the timeline in a moment. So in the autumn, students are randomly allocated to study groups of generally 5 to 6 students. So we end up with lots of groups because it's such a large module. For the rest of the year, students then face a combination of group tasks, group assessed tasks in macroeconomics, and also individual assignments, so an individual exam at the end, and of course individual assessments in students' other modules. And what we do in this research is that we look at the characteristics of the students and the groups, and we use this to test for associations between these characteristics and group or individual academic performance. And we'll see that the timing of our data collection leads us to be fairly confident that what we identify are indeed causal associations. So this leads to two main research questions. Whether the composition of the group affects group task performance, so the grades this group gets for its group work, and secondly, whether the composition of the group actually affects individual learning. So that is the marks that students achieve in individual assessments which take place after working in that group. At this juncture, it's really useful to think about the timeline of our data collection. So we follow students for the entirety of their first year. Within a month of turning up, students in many modules will have a mid-term course test, an assessment. So we use these mid-term tests as an academic baseline because they occur before students are allocated to their groups. So there's no risk here that the group affects the grades that they get in these course tests. So this is our baseline academic ability. Students allocate their groups before Christmas. Shortly after Christmas, they have to submit their first group project, which is a video. We don't pay too much attention to this because there's very little variation in the grades. Most groups did very, very well here. Plus, students have not had a real chance to work together because that occurs later. So they're encouraged to work together to study for the rest of this term. So Easter happens. Immediately after Easter, they submit a much more substantial group written project, which is the product of the work that they've done together. And then after that, they have their standard first year exams. All exams take place in this summer exam period. So they have exams in macro and in a selection of other modules. So from this data collection, we gather information on around 1,500 students and around 270 groups. So we have information on students' characteristics, gender and nationality, this baseline measure of academic ability, we also have information on the groups that students are part of based upon the characteristics of the students within that. So the gender diversity or international diversity of each group, the general academic ability of members of the group, and we also collect information on students' academic performance. So that is performance in group tasks, pre-group assessments, which are baseline level of academic ability, and also other academic grades, specifically the grades in the end of year exams. So to address our first research question, that is thinking about group composition and group task performance, we aggregate all of this individual information on gender, nationality, ability to create information on each group. And we use these group characteristics to look at the association between these characteristics and the group performance in assessments, with the addition of a simple dummy variable for the academic year. So we end up with a very noisy set of results, but we do see some evidence around nationality and diversity of nationality, and also evidence of a slight drag on group performance based on the presence of low ability group members. I'm mainly going to focus on this nationality and diversity issue. So we find a positive association between international diversity within a group and group performance, and that as we decrease the diversity within groups, that actually these groups tend to get worse marks, with one exception. When that decrease in diversity results in more British students in the group, and this we attribute probably almost certainly to the cultural advantages that British students have at UK universities. Addressing our second question, which concerns the link between group composition and individual academic performance after being in a group, we need to consider group and individual level variables. So our group variables are very similar to the ones that we had in the previous one. We have a measure of gender diversity, international diversity, academic abilities of group members, but we also include in the second regression the grades that this group achieved in its assessments. We also include individual characteristics around gender, nationality, individual academic baseline ability, and finally we include some interactive variables. That is, think about whether women perform better in groups with more women, and also the idea of going back to the previous set of results, whether or not being British in a dominant national group makes a difference. So within this model, using individual academic performance in the macro exam, an average mark for all other first year exams in theory unrelated to the macro group work, and also looking at year 2 academic performance, we include, as I say, all of these three things: the group characteristics, the individual, some interactive variables, and again some dummy variables, just looking at the academic year to control for cohort effects. So I'm not going to pay any attention to that table over there because it's a very messy set of results, but we do see some possible associations between nationality and being part of the majority group nationality, and some effects with gender. The results we find on nationality are similar to those in the previous regression, in that being a member of a majority national group within the group actually results in worse academic performance in individual exams, except if you are British and part of a majority British group within your study group. So where actually it's associated with positive performance. Strangely, this group majority effect flips when looking at the year 2 results. We don't really know what that means just yet. We actually find some very fascinating results with regards to gender. So we observe at a baseline an awarding gap where women tend to perform less well than men in their final exams. But we see that actually the proportion of women in the study group affects the final exam performances. And these are exams excluding macro. These are all exams completely unrelated to the study group. So what we find is, as the proportion of women in the study group increased, this is associated with improved academic performance in final exams for women. Whereas actually male academic performance in the final exams falls as the proportion of women within their study group increased. So we have some really fascinating working hypotheses here. So we saw this international diversity effect with group task performance, where increased diversity was associated with improved group performance, where concentrations of single nationality aren't helpful, except if it's a concentration of British students. And this probably has its roots in, certainly this result has its roots in sort of the cultural advantages that British students probably have. The gender effect and also the nationality effect with regards to individual performance leads us to start thinking that actually what we're observing is the emergence of spontaneous study groups. So actually, the more women you have in a group, the more likely it is that they will then form, if you like, a mutually supportive study group, which will help them in all of their exams. This may also be happening with on a national basis for British students. So there is some evidence that group composition matters. So there are some implications around nationality, there's implications around gender, especially the important implications in terms of avoiding isolating women in predominantly male groups where they are likely to underperform as a result. And there's some really, really interesting stuff that we're looking into around the role of study groups in fostering communities of study, and if you like, and the idea of formal study groups birthing spontaneous study groups. So this video has featured just a summary of our work in progress results. If you found it interesting and you want to know more about this project or our more general research looking at diversity and inclusion economics, you can contact my co-author, Stefania Paredes-Fuentes of the University of Southampton, or you can contact me, Tim Burnett, at Aston University. I hope you find this video informative and maybe entertaining, so thank you very much.
Hi, my name is Tim Wong from the Department of Economics at the National University of Singapore. In this presentation, I will detail 2 group projects that I've implemented in an undergraduate level elective in industrial organization. These projects are designed to allow students to make hands-on connections to the real world. They have to collect and interpret data with the goal of making causal inference. Now, before I dive into the details of the project, here's a quick overview of the course. Students typically take this course in their 2nd or 3rd year after taking a core course in microeconomic theory, which covers consumer theory and firm theory. Now, this industrial organization course first covers monopoly markets, including topics like price discrimination, product differentiation, and product bundling. Next, students are introduced to game theory, covering topics such as simultaneous and sequential competition and collusion. Now, the 2 projects are assigned after we discuss price discrimination and simultaneous competition. The first project is on price discrimination. In class, students learn about the necessary conditions to practice price discrimination, and that is the ability to set different prices, for example, as a monopolist who can identify different market segments, and the ability to prevent arbitrage. Then students learn models of 1st, 2nd, and 3rd degree price discrimination. The second project is on price dispersion. When learning about oligopoly markets, the models that are taught assume that identical products sell for the same price. I proceed then to discuss a paper by Sorensen, which shows that prescription drugs, which are homogeneous, sell for different prices in pharmacies due to price surge. In particular, drugs that are purchased more frequently exhibit less price dispersion because buyers search more intensely for lower prices with such prescriptions. Next, let me briefly walk you through the price discrimination assignment and a sample of student work from this assignment. Here, students are tasked with investigating price discrimination practices by a ride-hailing operator. They need to justify that the operator has the ability to price discriminate, then hypothesize dimensions over which the operator might price discriminate. For example, they may charge different prices for the same trip for business travelers versus leisure travelers. Next, the students need to design and implement a data collection process to test the hypotheses they have made. At this stage, I brief the students on the concept of experimental design. In particular, that to obtain causal results, they need to have a control group and they need to hold all else constant. Students then present their findings in class to the instructor and their classmates. And this is followed by a discussion involving the entire class on the project they have just seen. Now here's a sample of some of the work done by the groups. Here we have a group that hypothesized that the ride-hailing operator would charge different prices to different users based on how frequent the users were on the app. Next, what they did is they got together and searched for the exact same trips in an effort to hold everything else constant. They discovered that when only the user varied, the frequent user was offered a higher price than the other users. From this, they concluded that the firm price discriminated against this frequent user. In the discussion that followed, I asked the class to think of other reasons why the frequent user could have been charged a higher price. Students then began asking the group what else about the different users' accounts could be different, besides the fact that one user was more frequent than the other. Next, let's discuss the price dispersion assignment. Here, students are told to select a few homogeneous products that they hypothesize vary in the extent of price dispersion because of variations in the extent of price surge. Here, students must find a variable that proxies for the extent that consumers search for lowest prices and show some correlation between this proxy and the extent of price dispersion. We draw parallels here to Sorensen's study, where the frequency with which a consumer must repurchase their prescription is used as a proxy for how much the consumer will search for lowest prices. Here is an example of student work from this project. This group chose to compare the price dispersion for petrol to the price dispersion for convenience store items sold within the same petrol stations. Their hypothesis is that since petrol prices are easy to search, since these prices are listed online, that price dispersion will be low. And in contrast, convenience store item prices are harder to search since they are not listed online. Using the coefficient of variation as their measure of price dispersion, this group does find that petrol prices are less dispersed than convenience store item prices. In this presentation, we discussed other reasons why convenience store items might have greater price dispersion, besides the fact that it could be price surge. For example, maybe the shopping experience in some of these convenience stores in the petrol stations are more premium than in others. I would like to conclude by providing some reflections on this project. One of the most noticeable outcomes is a large variation in the quality of work among groups. This is because students have varying degrees of exposure to empirical methods when they enter the class. I do have to reassure a weaker group that they have not done poorly. In fact, the weaker group's presentations serve as a greater opportunity for learning through the discussions that follow. But some encouragement is necessary post-presentations. I think students could benefit from a pre-project meeting with the instructor. That might improve outcomes. So I have not yet tried this. And that concludes this presentation on group projects in industrial organization.